Hi students, so good evening everyone, and welcome to our third session on the sets for IIT Mains, NDA and KCET. Okay, so in this class we are going to continue our concepts for this class from where we have left from the yesterday. Okay, so hello and hi everyone. So quickly tell me everyone, the voice is clear or not? Quickly tell the voice is clear or not, and is it audible or not, and video is good or not? Quickly tell me. So this all things we have completed in the previous classes. So we have completed the types of sets also. Today we are going to for our the next concept, properties of power set is also over. Okay, that means we have to start with Venn diagram, correct? Okay, we have to begin our class with Venn diagram, no problem. So let us start our concept with Venn diagram. Okay, so what is Venn diagram? Let us first understand, then let us take some small example and we can go for the next concept. Okay, so Venn diagram means it is the diagrammatical representation, or you can say the representation of sets, with diagram is known as, or it is called as Venn diagram, okay, clear? That means the given set you have to represent with diagram. For example, here I have taken one example that you can see. Here I am representing the set A diagrammatically. So here I am representing set A diagrammatically, so that you can see set A has 3 elements and another elements are not in set A. So see here, this is in set A, this is in set B, this is in set C, but these elements are not in set A. That means 1 is in A, 2 is in A, 3 is in A, but the remaining elements are not in A. Clear? That means it is called the diagrammatical representation of set. Here you have universal set as set of, you can take according to the diagram 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so this is U, that is universal set. So U is equal to 1, 2, 3, 4 so on to 10. That means in the universal set you have 10 elements, and in the set A you have 3 elements, 1, 2 and 3, 1, 2 and 3. Okay, so using this you can say in this Venn diagram set A contains 1, 2, 3 and universal set contains the remaining elements, that is 4, 5, 6, 7, 8, 9 and 10. Clear? So from this you can understand the diagrammatical representation of the set is called Venn diagram. See, 1 is present in A, 2 is present in A, 3 is present in A. Okay, and here you can just see the remaining elements, that is 4 is present in U, 5 is present in U, 6 is present in U, 7 is present in U, 8 is present in U, 9 is present in U, 10 is present in U. This 4, 5, 6, 7, 8, 9 and 10 are present in your universal set, but they are not present in set A. Okay, and elements 1, 2, 3 are present in set A, but they are not present in set U. Clear? So from this you can understand this is the diagrammatical representation of set A as well as set U. Clear? So from that you can just go through your Venn diagram definition, that is the diagrammatical representation. That is the diagrammatical representation of the sets is called Venn diagram, or the representation of the sets in the diagrammatical form is called set. Okay. So I think all of you have understood this. So let us go for one more problem. Let us go for one more problem. See, I will take U as having A, B, C, D, E, F, G, H. Okay. Set A has A to H. Now, set A is A, B, C. Set B is F, G, H. Now, I have to represent this in Venn diagram. Now, I have to represent this in Venn diagram. So, that will be, this is called U. This square is called U. I have two sets, that is A and B. I have two sets, that is A and B. Now A has small a, small b, small c. This is set A. And B has F, G, H. Okay. And this is set B. Clear? And the remaining elements are D and E. Remaining elements are D and E. They are not in set A as well as they are not in set B. Okay. A, B, C are present in set A, F, G, H are present in B, D and E are present in U. So, this diagrammatical representation of the sets is called Venn diagram. The diagrammatical representation of the sets is called Venn diagram. Okay. So, now we can go for operation on sets. That means now you understood what is set, types of set, what are the properties of the types of set and all. Now we have to go for operation on sets. Clear? And the first operation on the set is union of two sets. Union of two sets. And the second one is intersection of two sets. Second one is intersection of two sets. Third one is disjoint of two sets. Third one is disjoint of two sets. And the fourth one is difference of two sets. Fifth one is symmetric difference of two sets. Fifth one is symmetric difference of two sets. And sixth one is complement of a set. Okay. So we have 6 operations to discuss. That is 1. Union, everyone knows. Intersection, everyone knows. Disjoint, only few of you are knowing about it. Difference of sets, only few of are knowing it. Symmetric difference, very less people know what is symmetric difference of two sets. Complement of set, also known to very less people. Okay. But union and intersection is known to everyone, I know. Now we have to understand disjoint, difference, symmetric difference and complement of a set. Okay. Let us start this. Union of two sets. Union of two sets means, see here, if I have set A and set B. If I have set A and set B, A union B is written as collection of X such that X belongs to A or X belongs to B. X belongs to A or X belongs to B. That means, see here, if A has 1, 2, 3, if B has 2, 3, 4, now A union B equal to, what you have to collect? The elements such that it must be in A or B, no problem. So see here, 1 is present in A, I can write this. 2 is present in A, I can write. 3 is present in A, I can write. See, 2 and 3 are also again present in B, but no problem. Don't repeat them. Only extra term is 4. So this is going to be A union B. This is going to be A union B. Clear? So I think you can understand this. What is A union B? So A union B is the collection of X such that X belongs to A or X belongs to B. Clear? Okay. So now let us go for the next concept. Before I go for the next concept, you just go through it. That is A union B will be equal to X such that X belongs to A or X belongs to B. X belongs to A or X belongs to B. So now you just go through this. Very important. See here, with this diagram, I want to explain one very important thing. First one, what if A is subset of B? What if A is subset of B? Second one, what if B is subset of A? Third one, A is not subset of B and B is not subset of A. And fourth one is A and B are disjoint. A and B are disjoint. Okay. So what happens in these conditions? That is very important. So see here, my dear students, you are going to write A union B. Clear? So now you just see, if A is subset of B, what is meaning of this? A is subset of B implies every element X in A is in B. Every element of A is in B. So now if I calculate A union B, what happens? See here, all the elements of A are in B. All the elements of A are in B, right? If all the elements of A are in B, then what it implies or what it will be equal to? It will be equal to B. It will be equal to B if A is subset of B. If A is subset of B, because B contains every element of A. B contains every element of A. Therefore, A union B is going to be equal to B. I think you need an example. So here you just see it. That is, if A equal to 1, 2, B equal to 1, 2, 3, 4, 5. Okay. So here you can just see A is subset of B. A is subset of B because every element of A are in B. Now if I make A union B, what will be A union B? You take A union B, it will be 1, 2, 3, 4 and 5. What is meaning of this? A union B is nothing but your B. You can just see here, B and A union B are both same. B and A union B are both same. This type of things are very essential because this is not your theory exam preparation. This is JEE Mains preparation, so that you have to study like this, which is very important. Which is very important. Okay. So A union B is 1, 2, 3, 4, 5. B is 1, 2, 3, 4, 5. Therefore, A union B is going to be equal to B. Hence, you can conclude this result. Okay. That is what we were discussing. What happens if A is subset of B? If A is subset of B, A union B is going to be equal to B. A union B is going to be equal to B. Clear? Okay. So now what about the second one? You just see what happens if B is subset of A. What happens if B is subset of A? What happens if B is subset of A? Quickly tell me. What happens if B is subset of B? What is A union B equal to if B is subset of A? if B is subset of A. Already we have discussed one result. On the basis of that, I am asking the second one. So I think everyone can understand that, and you can tell me the answer for the second question. Very good. A union B is going to be equal to A, because you can just see, you take A equal to 1, 2 and you take B equal to 1, 2, 3, 4. See here, A is subset of B. Now A union B is going to be equal to 1, 2, 3, 4. Therefore, that is nothing but equal to B. So A union B is equal to B. Sorry, here you can just see A is subset of B. So we need B is subset of A, right? Okay, let us take another example. That is, B is subset of A. So let us take B is subset of A. So for that, you take the first set as B. You take the first set as B and you take this set as A. So now B union A will be equal to what? 1, 2, 3, 4. And you can see that it is nothing but equal to set A. Why? Because here B is the subset of A. Why? Because here B is the subset of A. Clear? So this I have explained here. Okay. So now I think everyone have understood this. If A is subset of B, A union B is going to be equal to B. Okay. If A is subset of B, A union B is going to be equal to B. If B is subset of A union B is going to be equal to A. Everyone give me big smiles if you have understood this. Quickly tell me, have you understood this? If you have understood this, I can go for the next thing. That is, suppose A is not subset of B, B is not subset of A, what happens? Okay. See here, if B is subset of A, take B as 1, 2, A as 1, 2, 3, 4. Now B union A is 1, 2, 3, 4. That is nothing but equal to A. Okay. So see the Venn diagram. What happens? Already you know here Venn diagram is present here. So let us don't worry about that. But you remember this property. You remember this property. Clear? Okay. So now let us go for what happens. What happens if A is not subset of B, B is not subset of A. So see here, I will take A equal to 1, 2, 3, 4. I will take B equal to 3, 4, 5, 6. See here, A is not subset of B and B is not subset of A. A is not subset of B and B is not subset of A. Okay. So for that you can just see, because A has 1, 2, 3, 4, B has 3, 4, 5, 6. Here A is not subset of B as well as B is not subset of A. So now if I do A union B, it will be equal to 1, 2, 3, 4, 5, 6, which is not equal to A as well as which is not equal to B. It is not equal to A as well as it is not equal to B. That means A union B is not equal to A. On the same way, A union B is not equal to B. Clear? So very, very important. If A is not subset of B and B is not subset of A, you are going to get A union B is not equal to A and A union B is not equal to B. Clear? So like this, you have to understand the properties. See my dear students, if I explain like this, this is the preparation of JEE Mains. If I just write the definition, that is the preparation of board exam. Just this is the difference. Just this is the difference. Okay. By understanding the concept, we should solve the multiple choice questions. By by-hearting the concepts, you should write the board exam questions. That is what the difference. There is no much big difference. The efforts what you put for board exam, the same efforts you have to put for JEE Mains preparation. That means definitely you can do good. Definitely you can do good. Okay. So now this is over. Next I will take, see here, A equal to 1, 2, 3 and B equal to 4, 5, 6. You can see that A and B doesn't have any common elements. A and B doesn't have any common elements. That means A intersection B is equal to empty. Here you can see A intersection B equal to empty. Okay. So it implies A union B is equal to 1, 2, 3, 4, 5, 6. Okay. So this is what A union B. This is what your A union B. Clear? Okay. So now I think all of you have understood what happens if A is subset of B to the A union B. What happens to A union B if B is subset of A, and what happens if A is not subset of B as well as B is not subset of A. Okay. So from this I will write some note here. If A is subset of B, then A union B is dash. If B is subset of A, then A union B is dash. Equal to, you can write no problem. Okay, equal to what? If A not subset of B, then A union B is what? Okay. So here you have to write the questions and answers. Clear? So I think you can fill in the blanks. You can fill the blanks which I have left, and you can also write what will happen for A union B if A is not subset of B and B is not subset of A. B is not subset of A. Clear? Okay. So now we can go for the next concept, that is intersection of two sets. That is intersection of two sets. Clear? Okay, you do that homework later. I will go for intersection of two sets. A intersection B means these are the elements X such that X belongs to A and X belongs to B. X belongs to A and X belongs to B. That means the X has to be in both the sets A and B. The X has to be in both the sets A and B. Okay. That means you can just see here, if A is equal to 1, 2, 3, 4, 5, B is equal to 3, 4, 5, 6, 7. What is A intersection B? See here, what are the common elements? 3, 4, 5. These are the common elements that we have to write in A intersection B. That we have to write in A intersection B. Okay. So if we write them in A intersection B, then they are going to be called as the common elements. So therefore 3, 4, 5 is going to be in the set A intersection B. Clear? Okay. So now we can go for the next concept, that is what happens if A is subset of B for A intersection B. What happens if B is subset of A for A intersection B? Clear? On the same way, if A is not subset of B and B is not subset of A, B is not subset of A, what happens for A intersection B? That we have to understand. Clear? So can anyone tell me, if A intersection B, then what happens for A intersection B? If A is subset of B, then what happens for A intersection B? Then what happens for A intersection B? Can anyone tell me quickly? So quickly tell me this. Okay. So if you get confused, you just take the examples of A and B. You just take the examples of A and B with another example where A is subset of B. 1, 2, B is 1, 2, 3, 4. Okay. So now here A is subset of B. So now what happens for A intersection B. So you are going to write 1 comma 2. That is nothing but equal to A. That is nothing but equal to A. Very good. All of you have given the right answer. Again for the second one, if B is subset of A, what happens for A intersection B? What happens for A intersection B? What happens for A intersection B? In the second case, quickly tell me. It will be B. It will be B. Okay. Clear? So now you can just see. Very good. So most of you have given the right answer. That means all of you are understanding the concepts very nicely. Most of you are giving the right answers. That means all of you are understanding the concepts very nicely. Very good. Keep it up. Okay. Now you just go for the next conditions. For that I have taken this example. A is not subset of B as well as B is not subset of A. What happens for A intersection B? You get 3, 4, 5. That means, see here, A intersection B is not equal to A as well as A intersection B is not equal to B. A intersection B is not equal to A as well as A intersection B is not equal to B. Clear? So really the class is going very nicely. I feel very happy with your answers. I feel very happy with your answers because most of you are giving the right answers. Some of you are in little bit confusion. No problem. No worries. That means all of you are following the concepts. That means all of you are following the concepts. So who all not subscribed the channel, tell them to subscribe the channel. And for your friends also, you can tell to subscribe the channel. And on the same way, you have to give what? Click on bell icon. Click on bell icon. So you can get the notification whenever I come live. Whenever I come live, you can get the notification. No problem. Okay, let us go for next, disjoint of two sets. See my dear students, disjoint means no common elements. That means suppose A has 1, 2, 3, 4. B has 4, 5, not 4, 5, 5, 6, 7, 8. 5, 6, 7, 8. 5, 6, 8 and 7. You can write like this. No problem. Okay. So now you just see here A intersection B is equal to empty. You can just see here A intersection B is equal to empty. Okay. So that means you can also see A is not subset of B and B is not subset of A. Therefore, if A intersection B is empty, if the sets are disjoint, then A is not going to be the subset of B and B is not going to be the subset of A. So therefore, we say that the two sets are disjoint. We say that the two sets are disjoint. Very simple concept that you can understand. Clear? So now let us go for very important concept. Very important concept. That is difference of two sets. Difference of two sets. You see here, difference of two sets is always written as A minus B. Difference of two sets is always written as A minus B. The meaning of this is collection of X such that X belongs to A but X not belongs to B. X belongs to A but X not belongs to B. That means, what is meaning of this? X not belongs to B means X belongs to B complement. I think about complement you have not yet studied, but no problem. Complement means which is not present in B. Complement means which is not present in B. Okay. So therefore, you can just say X belongs to A or athwa you can say and x belongs to A and x belongs to B complement. X belongs to A and x belongs to B complement. Or you can also say it as x belongs to A x belongs to A but x not belongs to B. For example, we can take two sets. For example, we can take two sets, that is A equal to 1, 2, 3, 4, 5, 6, 7, 8. You can take B as, see here, 6, 7, 8, 9, 10. Now I want to write A minus B. See here, if I want to write A minus B in this set, it must be in A but it must be not in B. See here, 1, it is in A but that 1 is not in B. This 1 is present in A but 1 is not present in B. Therefore, I can write it here. Clear? Next you see 2. 2 is present in A but not in B. I can write it here also. Next you see 3. 3 is present in A but not in B. I can write it here. 4 present in A but not in B. So this is 4. 5 present in A but not in B. Right here 5. 6 present in A as well as 6 present in B. So I can't write. 7 present in A, 7 present in B. I can't write. 8 present in A, 8 present in B. So I can't write. So all the elements of A are over. So we should close this. Don't worry about these elements 9 and 10 in the set B. If you verified for all the elements in set A, then A minus B is over. Clear? So A minus B is set of 1, 2, 3, 4 and 5. Clear? So quickly tell me all of you, have you understood this? Okay. So this is very important concept. So with the example, all of you have understood. I think all of you have understood. So now you just see this diagram. Okay. A minus B. A minus B means elements which are present in A. A minus B means elements which are in A but not in B. B minus A means elements which are in B but not in A. Okay. So you can write x belongs to A minus B implies x belongs to A but x not belongs to B. X belongs to B minus A implies x belongs to B but x not belongs to A. All the things are same. So this you can understand. No problem. So here coming to this, you just see A minus B is not equal to B minus A. Very important note. A minus B is not equal to B minus A. A minus B is always subset of A. B minus A is always subset of B. A minus B is always subset of A. B minus A is always subset of B. You can verify it, no problem. So you take set A. You take set A as 1, 2, 3, 4. You take set B as 3, 4, 5, 6. So now what is A minus B? A minus B is 1, 2. A minus B is 1, 2. Okay. So you can verify that A minus B is subset of A. A minus B is subset of A because every element of A minus B is present in A. Every element of A minus B is present in A. On the same way, B minus A you calculate. If I calculate B minus A, I will get 5, 6. If I calculate B minus A, I will get 5, 6. You can see that B minus A is subset of B. B minus A is subset of B. Okay. So from this you can understand A minus B is subset of A. B minus A is subset of B. B minus A is subset of B. Clear? So quickly tell me all of you, have you understood this? Quickly tell me, all of you, have you understood this? A minus B will be the subset of A, B minus A will be the subset of B. Okay. On the same way, A minus empty set is equal to A. You can see that if I subtract this A with empty set, I will get A. A minus A will be equal to empty set because all the elements are going to be deleted. On the same way, A minus B and B minus A are disjoints. They are disjoints because they are not going to have any common elements. A minus B and B minus A are not going to have any common elements. Clear? So first two nodes you have understood. What about the next two nodes? A minus empty. Empty set. Empty means empty set. A set minus empty set is going to be equal to A. You can see here. If I do this, every element of A I has to repeat here. Every element of A I has to repeat here because empty set has no elements. Empty set has no elements, so that's why I have to write all the elements of A. Next, if I delete all the elements of A from A, it is going to be equal to empty. Clear? And anyways, the last one is A minus B and B minus A are not going to have any common elements. You can just see here. A minus B and B minus A both are disjoint because they are not having any common elements. They are not having any common elements. So from this, I think you have gone through very important notes, and also I feel that all of you have understood what is difference of sets. What is difference of sets? Okay. Next, symmetric difference. You just see what is symmetric difference. Difference of the set is very different from symmetric difference. There are two difference. One is symmetric difference of two sets. Another one is only the difference of two sets. See, the previous one was difference of two sets. This was difference of two sets. And the next one is symmetric difference of two sets. The next one is symmetric difference of two sets. Okay. Symmetric difference of two sets means that you can see here A delta B. We write it as A delta B. That will be equal to set of X such that X belongs to A union B or A minus B union B minus A. X belongs to A minus B or B minus A. A minus B or B minus A. Okay, that means A minus B union B minus A. This is called the symmetric difference. This is called the symmetric difference. X belongs to A minus B. Here OR means union. B minus A. Clear? So that means you have to take the union of A minus B and B minus A. Okay? That you can see here. See this A delta B. That means the elements which are present in A minus B as well as elements which are present in B minus A. Already you know how to calculate A minus B. Already you know how to calculate B minus A. If you take union of this, that will be the symmetric difference of A and B. That will be the symmetric difference of A and B. So I think you all need an example to get convey with this. Don't worry, I will take an example. You see here A equal to 1, 2, 3, 4, 5. B equal to 4, 5, 6, 7. Okay. What is A minus B? You just see A minus B is going to be 1, 2, 3. A minus B is going to be 1, 2, 3. Clear? A minus B is going to be equal to 1, 2, 3. Okay. What is B minus A? You just see B minus A is 4 and 5 are present. So 6, 7. Clear? So now A delta B. A delta B is equal to A minus B. A delta B is equal to A minus B union B minus A. A minus B union B minus A. That will be equal to, you just see here, I will write here only 1, 2, 3, 6, 7. This is called symmetric difference. This is called symmetric difference. Okay. So difference of a set is very much different from symmetric difference of two sets. Please understand, very big concept, very important concept. Symmetric difference is a very much different from the difference of two sets. Clear? So I think everyone have understood this. Everyone have understood this. Next, see the note. Next, see the note. That is, A delta B is also written as A delta B is also written as A union B minus A intersection B. Is also written as A union B minus A intersection B. You can say this as it is the another formula. It is the another formula. Okay. A minus B union B minus A. This is one formula, and the another formula is A union B minus A intersection B. A union B minus A intersection B. Clear? So please understand this, the second formula, that is A union B minus A intersection B. You can apply to this example. So homework case, you verify A union B minus A intersection B. Verify this and check you are going to get the same answer or not. Verify and check you are going to get the same answer or not. That is A union B minus A intersection B. Clear? So this is the homework. You have to verify A union B minus A intersection B. You have to verify it with this answer. You must get the same answer. You must get the same answer for this example. Okay. So now, let us see. Very good, Sanju. Got the right answer. Very nice. Very impressive answer. Clear? Very good. So see, the second one. A delta B is equal to B delta A. A delta B is equal to B delta A. That means it is commutative. That means it is commutative. You just see here. A symmetric with B is equal to B symmetric with A. Is equal to B symmetric with A. Clear? Already you got here asymmetric B. Already here you got asymmetric B. What is B symmetric A? Again the same thing. Again the same thing. That is B minus A union A minus B. B minus A union A minus B. Clear? So again you are going to get the same result. Again you are going to get the same result. Clear? Therefore A delta B is equal to B delta A, but very important thing is here. See this. A minus B is not equal to B minus A. This is difference of two sets. Difference of two sets. Difference of two sets is not commutative. Difference of two sets is not commutative, but symmetric difference is commutative. Difference of two sets is not commutative, but symmetric difference of two sets is commutative. Very much big difference. Okay. So what is the difference of, what is difference between difference of two sets and symmetric difference of two sets? Symmetric difference of two sets is commutative and difference of two sets is non-commutative. Please remember, very important note. Very important note, that is difference of two sets is not commutative, but symmetric difference is commutative. But symmetric difference is commutative. I can write it here. Note. Right here, that is difference of two sets is commutative. Okay. Sorry, is not commutative, but symmetric difference is commutative. Okay, so please understand this. Very important note. Such type of notes you have to make clear, then only you can do some different things from the others. Okay, what all will do, they will read symmetric difference, they will read difference between two sets, but this note making so many of students will not do. So, but when you are studying for good exams, this type of note making is very important. Okay, now let us go for complement of two sets. Okay, complement of set means, see here, if I have A as 1 2 3, universal set is 1 2 3 4 5 6. Now if you want to write complement of A, you have to take U minus A. That will be equal to elements present in U but not in A. Elements X such that X is present in U but X is not in A. That means set of 4 5 6, which are not in A, clear? So such type of elements are called as 4 5 6. So it is called as A complement. Clear? So I think everyone can understand this complement set, no problem. That is 4 5 6. Clear? Okay, very good. So quickly everyone solve this and tell me the answer. Here, see, in the same 7th problem, you have first question, you have second question, you have third question with these 4 options. This is not only 7th question, you have 3 questions. First you have to solve A union B whole complement. Next you have to solve A complement intersection B complement. Next you have to solve A symmetric B. Okay, so I will solve one and I will give 2 problem as homework. Are you happy with that? I will solve one and I will give 2 problems as homework. So I will solve A union B whole complement. Okay, this is nothing but U minus A union B. What is U? U is 1 2 3 4 5 6 7 8 9 minus what is A union B? You just see A union B is 2 3 4 5 6 7 8. A union B is 2 3 4 5 6 7 8. 2 3 4 5 6 7 8. Now this will be equal to U minus A union B. 1. Okay, 9. 2, 3, 4, 5, 6, 7, 8 are deleted. 1, 9 is my answer. 1, 9 is my answer. Okay. Next, A complement intersection B complement. You can solve A complement intersection B complement. What is A complement? You just see here. A complement is 2, 2, 4, 6, 8. Write 1, 3, 5, 6, 7, 9. So this is A complement. What is B complement? You write 4, 2, 3, 4, 5, 6, leave 7, 8, 9. So this is B complement. Intersection of this is, you can just see 9. Okay, you can see 6. Clear? So this is 6, 9. Check once. A complement intersection B complement. A complement intersection B complement. A complement is 1, 3, 5, 7, 9. B complement is, I can't write 1, I can write here because in B 1 is not present. So 1, 6, 9. Clear? So you just check A complement intersection B complement. Once more you check A complement intersection B complement. B complement I can write 1. Next I can write 4. I can write 6. I can write 8. I can write 9. So now A complement A complement intersection B complement. A complement intersection B complement will be what? This will be equal to the common elements 1, 6, 9. The common elements 1, 6, 9. Okay. Okay, sorry. 6 is not present in A complement. Sorry for that. 6 is not present in complement of A. And 6 is not present here also. So 1, 9. Sorry for that. You will get only 1, 9. We will get only 1, 9. Clear? Very good. So we will get only 1, 9. Okay. So see here, A intersection, A complement intersection B complement is 1, 9. Okay. Now go for asymmetric B. What is asymmetric B? A minus B union B minus A. A minus B union B minus A. So what is in A minus B? In A minus B we have, we can write 4 which is present in A but not in B. We can write 6. We can write 8. Okay. So A minus B union B minus A. You check B minus A. I can write 3. I can write 5. I can write 7. That will be 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Okay. So therefore our answer is a set of 1, 9, set of, another one is, you can just see 1, 9. Another one you can see 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. So therefore 1, 9, 1, 9 and 3, 4, 5, 6, 7, 8. So what is your option? Which one is the correct option? Option B. Option B is right. Option B is right. Clear? So my dear students, if you know De Morgan laws, it is very easy because De Morgan law tells that A union B whole complement is equal to A complement intersection B complement. So till now we have not gone through our De Morgan's law, so that's why I have solved all this. But If you know the De Morgan's law tells that A union B whole complement is equal to A complement intersection B complement. So see here, A union B whole complement is equal to A complement intersection B complement. So from that directly you can take, okay, 1, 9, 1, 9. Directly you can go for the third case. Okay. So therefore you can see that option B is correct answer. So quickly tell me, all of you, have you understood this? Quickly tell me, all of you, have you understood this? Okay, we can go for the 8th problem. So you only tell me the answer for the 8th problem. The shaded region in the figure is, you just see, this is called what? A union C. The red portion is A union C. The black portion is purely B. So I want black portion. So tell me the answer. Anyone, have you got the answer? X present in B, but X not present in A union C. What this diagram tells? See here, X present in B, but X not present in A union C. Okay. Some of you telling that B intersection A union C, that is wrong. Some of you are telling that B intersection A union C, that is wrong. I want black portion. That is elements which are in B but not in A union C. Elements which are in B but not in A union C. So therefore, here you can see that the answer is fourth option. Clear? Because I need black portion. See here, I need this shaded region. So if I want to say this shaded region, that is what? It is purely B. Here you can see it is purely B. Okay, what is the meaning of purely B? In this B, there are no elements of A, there are no elements of C. That means elements are present in B but not in A union C. Therefore, option D is the correct answer. Clear? Okay, so we can continue tomorrow. With the 9th problem. Try to solve this 9th problem before you come to the tomorrow class. And in the today's class, I have given some homework. Please do that. Okay. So please maintain the notes. Clear? So everyone, how are the classes? Are you following the classes? Are you understanding the classes? Please tell me. Are you understanding the classes? Quickly tell me. Are you understanding the classes? So try to attend the classes regularly. And everyone, thank you. Bye. Take care.